Hey guys, we are going to solve systems of equations using what we call Cramer's rule. So Cramer's rule is going to, like I said, solve these equations, but we're going to use matrix determinants. So here's an example of what a system of equations looks like. So we have two equations with both x and y, and our goal is to solve for both x and y. So this is going to be one method that we can use. So our definition of Cramer's rule, if we have two equations with two variables, so our x and our y are going to be variables, a, b, c, d, e, and f are all coefficients or constants. So if we have two equations, then we can find our solution, our xy solution, using these determinants. So remember, straight brackets means determinant of this 2 by 2 matrix. So we're going to plug our E and F values in and our B and D coefficients in. The denominator is what we call the coefficient matrix. So we take all of our coefficients and plug that into this 2 by 2 matrix. So it's really important that you copy this down because we're going to use that every single time we solve a problem like this. So let's jump into an example. Here I have two equations, 3x plus 2y equals -1 and 4x minus 3y equals 10. Our goal is to solve, find an xy solution. So we're going to use what we just defined as our x. So our numerator was E and F, and then B and D. So we plug those numbers in. Make sure you use the sign that's out in front. And then straight brackets or straight lines mean determinant. So 3 minus 20 gives us -17. Denominator was that coefficient matrix. So we have 3, 4, 2, and -3. So -9 minus 8 also gives us -17. Always divide this. So our x value would be 1. Similarly, if I plug numbers into my y value or my y determinant, I get 30 minus -4, which is 34. This bottom matrix, our determinant, didn't change. So really, you don't even need to write this in. You can just write -17 from the start. Okay, 34 divided by -17 gives you -2. So my solution, my xy solution for this system of equations is 1, -2. I'd like you guys to solve this system. And we can go ahead and classify our system based off of the denominator of each of those fractions that we've been dealing with. So we use capital D for determinant of our denominator, so that coefficient matrix. If that determinant does not equal 0, then we have exactly one solution. Okay, so if it's any number except for 0, we have one solution. We know we can find an answer. If it equals 0, there's a couple different scenarios. The first one, we would have no solution if neither of our numerators are 0. Okay, so if you get like 10 over 0 as your x and then -7 over 0 as your y, we know we can't divide by 0, so then we come to this rule and we say that our answer would be no solution. There is another case. You could have your determinant equaling 0 and have infinite solutions. You'd have infinite solutions if one or both of your numerators are 0. So we'll look at a couple examples. Here is our first one. 3x plus 2y equals 5 and 3x plus 2y equals 8. So if I go ahead and plug my numbers in, I get that my denominator is 0. So that raises our first problem. So I go and find my y. Obviously, the denominator is still 0. So here we have -9 and 6 as our numerators. Neither of those are 0. Therefore, we have no solution based off of our previous rules we just defined. No solution would mean that these two lines are parallel if you think about it graphically. Here's another example. So 3x plus 2y equals 5 and 6x plus 4y equals 10. Again, using our Cramer rules definition, we get 0 over 0 and 0 over 0 as our xy. We cannot divide by 0, which is why this poses a problem. So we go back to that classifying our systems rules, and since one or both of our numerators are 0, that means we have infinite solutions. Okay, and graphically that would mean that they're the same line.